Morning students, once again welcome back to the online sessions of class 10th mathematics. In previous class of maths, in a chapter 1 of real number, we discussing about how we can find the HCF of two numbers using the Euclid's division algorithm that we have to find into the previous class. Today also we discussing like how we can use the division algorithm lemmas, in which we have to prove that a number is in a form of 6m plus 1, or maybe the square of any number is 3m or 3m plus 1. This type of questions we are discussing into the previous class, and how this type of real numbers which can be represented onto the number line, as well as different type of the number system like natural, whole numbers, set of integers, rational, irrational, real, which all are discussing in the previous class. Now today we are discussing about the new topic that is called express the product of numbers on its prime factor. Now that is generally called as a fundamental theorem of arithmetic. By using this fundamental theorem of arithmetic, we have to find out, and in which I will use the specific topic in which express the number as a prime factor. For example, if I will take one number 140, if I will take 140, now this is the numbers as a form of prime factor, which is generally useful to find out the HCF of LCM between more than one numbers. In a questions, if more than one numbers is a part of the LCM and HCF that you have to find out, then we have to use this method as a product of prime factors. So how we can find the product of prime factors, in which I will take one example, that is 140. So 140, that should be using as a part of the division of a prime factor. How we can find out? If 140 that is divided by 2, answer will be 70, right? 140 that is divided by 2, that should be gives 70. 70 also divided by 2, that is 35. 35 is divided by 5, 5 sevens are 35, and 7 ones are 7, right? So what are the prime factors of 140? You write here, prime factors of 140, 2 raised to 2 into 5 into 7. So it is very easy. If you want to find out the prime factors by using these terms of 140, that can be by implementation is a part of division, we can be easily converted into a prime factor of 140. Similarly, I will take another example. I will take 156. I will take 156. Now 156, how we can find out? 156 that is divided by 2, that is 78. 78 to the 156. 78 which is also divided by 2, that is 39. 39 which is divided by 3, that is 13. And 13 divided by 1, 13 ones are 13. Right? So what are the prime factors of 156? Prime factor of 156 equal to 2, it is a 2 times 3 into 13. Right? So using this form, we can convert the formation of a prime factor. Now another example, I will take 3825. I will have another example, I will take 3825. How it can be converted? Now third one, 3825. Okay. So I want to factorize the form of prime factor of a 3825. How can I will divide this 3825? So first of all, 3825 which is divided by this, it is not divided by 2, so it is slightly divided with the 3. So 3 ones are 3, 3 twos are 6, 22, 3 sevens are 71, 1275. If you will divide 3825 with the 3, you will get the answer is 1275. Now similarly, once again I will move from division of 1275, that is divided by 3. So 3 fours are 12, right? 3 fours are 12 and 425. If 425 that is divided by 3, we will get the answer 1275. Now this is 425, it is generally not divided by 3, so it is divided with the 5. So 5. 8 5s are 42, remaining 25, 85. It is also divided by 5, 17 5s are 85. It is divided by 17 ones are 17. Right? It is like a tree structure. So if you use the prime factor of 3825, it gives you 3 square into 5 square into 17. Very easy. So by using this formation of a prime factor, you convert the number in a specific form into factor. We easily convert it in a form of factor. So now what is the use? What is the use of this prime factorization? So generally, it is generally used to compare more than one number as a form of HCF and LCM. We have to convert in a prime factor. So how it is useful to find out the HCF and LCM between the two numbers or more than two numbers? Let's take the one example. I'll take one example for that. I'll just find HCF and LCM. Okay. I'll just find the question. You find the HCF and LCM. So or also we have to verify the HCF into LCM is equal to product of two numbers. Okay. So here we can find out. Here just we find that find HCF and LCM. Also verify HCF into LCM is equal to product of two numbers, right? That we have to find out. So this is the question. This is the topic. Find HCF and LCM, and also we have to verify the HCF into LCM is equal to product of two numbers. For that, I'll take two numbers 26 and 91. I'll take two number 26 and 91. 26 and 91. I'll take the two examples there 26 and 91. So first I have to find out the HCF and LCM of these numbers, and also we have to verify the product of HCM into LCM is equal to the product of these two numbers. That we have to verify. The first priority to find the HCF and LCM of two numbers. So first of all, to find out the HCF and LCM, it is the primary step to find out the prime factor of this number, that is in a part of product of primes. So if I'll convert 26 as a form of prime factor, that is 13 to the 26. 13 to the 26. Similarly, if I'll convert 91, that is 13 into 7, 91, right? So now I have to find out HCF and LCM because we have converted this number as a form of prime factors. So therefore, HCF of 26 and 91. So HCF is the highest common factor. So common factor of the both numbers is 13. So HCF is 13. HCF is 13. Similarly, I have to find out LCM. So LCM of 26 and 91. To find out the LCM, first of all, in a common number having the maximum factor, that is written in LCM, so 13, and remaining two term is what? 2 into 7. 13 and 2 into 7, because if you write the LCM, you have to implement it the all numbers. So 13 into 2 into 7, 13 to the 26, 26 7s are 182. So LCM is what? 182, right? HCF is 13 and LCM is what? 182. So we have to also verify the relation between HCF into LCM is equal to product of two numbers. So to find out the verification, first step, to priority form of LCM and HCF is it a call as a LHS, and product of two numbers is called as a RHS. So sir, we check that LHS and RHS will be same or not. So here we'll write verification. Here I will write verification. So verification in which first I'll having the multiplication of HCM into LCM. So HCF into LCM, right? HCF into LCM. So HCF is what? 13. LCM is what? 182. So 13 into 182. Now 13 into 182, that is 2366. 366. So the product of HCF and LCM, that is what? 2366. Now also we have to verify the product of two numbers. Product of two numbers. Now which are the two numbers? That is 26 and 91. So 26 into 91, that is 2366. So if you see that first priority is what? We just find out the HCF and LCM of two numbers. HCF and LCM of two numbers, generally we have to find out using the product of prime factors, in which 26 and 91, that is converted into a product of prime factors. That will be HCF is 13, LCM is 182. Now in a second form of verification, HCF into LCM equal to what? 13 into 182, that will be 2366, as well as the product of two numbers 26 into 91, that is 2366. So both number will be same. So by using this method we can also verify the LCM and HCF as well as the product of two numbers. I'll take another example for that, and that should be easy for your clearance how we can be find. I'll take another slightly heavy number that should be used as a part of this question. Simple form, how we can be find out the formation for that. I'll take 336 and 54. I'll take another number 336 and 54. If you don't know how to be convert directly in a form of prime factor, you can use the prime factorization method. If you don't know how to convert that number in a prime directly in a prime factorization form, you can also be used as a 336 as a form of prime factor. Now how can we find out? I know that 16 into 3 into 7, 16 into 21. If you multiply 16 into 21, that will 336. 16 into 21, that is 336. So I will make converting into a form of prime factor. If you don't know how to compare the prime factor, we will use this method. 2, 1, 13, 6, 8, 168. 2, 8, 4, 2, 42, 2, 21, 3 and 7. See that 1, 2, 3, 4 times and 3 and 7. So if I want to write out 337 is equal to 2 raised to 4 into 3 into 7. Okay. Now what about 54? Prime factor of 54. Prime factor of 54, that is what? 6 nines are. 6 nines are is what? 54. Okay, yeah, what we have said that 27 to the 54. 27 to the 54. So I'll write here 2 into 3 raised to 3. Right? 2 into 3 raised to 3. That should be a 54. 3 into 3 raised to 3 is what? 27. 27 to the 54. So I'll get 2 into 3 raised to 3. Now I'll have to find out the HCF and LCM between two numbers first of all. Then we have to verify. Now HCF of 336, 54. Now when you write the HCF, between the two numbers, we have to first check which are the common numbers are seen in that two numbers. Which are the common numbers, and also in the common numbers which having the least power, that will return as a HCF. For example, if you see that 2 and 2 is the common number in both 336 and 54, there is a 2 is the common number, 2 and 2 in both numbers. But which having the least factor, that will return as a HCF. So here 2 raised to factor is 4, power is 4, and here 2 is the power of 1. So which term we have to use? 2 raised to 1 as a use as a HCF. Which have the minimum power, that is used as a HCF. So 2 raised to 1, it means 2. Now also we see that both number 3 and 3 is the common. Here the power of 3 is 3 and the 336 the power of 3 is 1. So which having the minimum power? 3 raised to 1. So I'll write here 3 raised to 1, that is 3. So 2 into 3 is what? 6. 2 into 3 is what? That is 6. So HCF of 336 and 54 will be 6. Now next is called LCM. We have to find out LCM. LCM of 336 and 54. Okay. Now in the term of LCM, that is slightly different from HCF. In HCF, we write the two numbers which is common and having the least power, that is written as a HCF, while having the common number in the formations which having the maximum power, which is written as a LCM. So if you see that 2 raised to 4 and here 2 raised to 1, which have the maximum power? 2 raised to 4. So I'll use here 2 raised to 4 as a LCM in both numbers, 2 raised to 4 into. Also we check that 3 is the common in both form, but factor is which having the maximum 3 raised to 3. So that is written 3 raised to 3 into 7, right? So 16 into 27 into 7. 16 into 27 into 7. If you multiply, so that should be 16 sevens are, that should whatever in 27, so it should be a 3024. It is a 3024 LCM. 3024, right? So we'll get the LCM is 3024 and HCF is 6. So by using this method of prime factorization, you can find the HCF and LCM. Now also we have to verify the numbers will be same as a part of the product. So how we can we use the verification? For the verification, we have to be used LCM into HCF, right? Is equal to LCM is what? 3024 into 6. Now if you multiply 3024 into 6, it always gives you 18144. 18144. That is the product of LCM into HCF. Now also we have to compare the product of two numbers. So product of two numbers, that will be 336 into 54, which is also give the answer 18144. 18144. So by using this method, we have just convert the numbers is a part of the prime factors. Also using that prime factors, we find the HCF and LCM of that numbers, and also we have to verify that the product of two numbers is equal to HCF into LCM. Okay. Now in the next question, I'll use more than two numbers. And by comparing that numbers, we have to find the HCF and LCM between more than two numbers. Okay. So find the LCM and HCF. That is the next question. Find LCM and HCF. More than two numbers are there, and how can we find these numbers? You can also use division algorithm method. If more than one questions in a question, more than one numbers are given, and if more than one numbers are given and you want to find out the HCF and LCM, so first of all we have to take on two numbers. In two numbers which have the maximum number and which have the minimum numbers, that should be compared, and whatever the answer is get to the HCF, that is compared with the third number. So that use division algorithm, whatever Euclid's method we have discussed earlier. But more than one numbers are given, so we mostly use the prime factorization method to find out the HCF and LCM. So to find out the prime factorization method of LCM and LCM, we take the two numbers. One example, 12, 15 and 21. Three numbers I will take. 12, 15 and 21, right? 12, 15 and 21. And I have to find out the HCF and LCM. The first is priority to find out its prime factor. So 12 its prime factor you have to find out, 15 you have to find out, and 21 you have to find out. So if you find out the prime factor of 12, 15 and 21, so if you convert the 12, how it can be converted? 4 3s are 12. 4 3s are 12. So 3 into 2 raised to 2. That should be 3 4s are 12. 15 how will write? 3 into 5 15. And 7 21 is what? 3 into 7. So all the numbers that is slightly converted on its prime factor, 12, 15 and 21, that is slightly converted on its form of prime factor. Now using that prime factor, I'll just find out the HCF and LCM. So first I'll find HCF 12, 15 and 21. So HCF is the highest common factor. So the common numbers in all these terms 12, 15 and 21, all this term having the common number, that is written as a HCF. So you see that in all three numbers the common number is what? 3. So HCF is called as a 3. That is called highest common factor. And next, least common multiplicator LCM, that is 12, 15 and 21. Okay. So all the numbers are written in a form of LCM if there is a common number having the maximum power which is written into LCM, and remaining all the numbers which is also included into the part of LCM. So 3 is the common in which all the terms 5 into 7 into 2 raised to 2, right? 5 3 is 15, okay? 15 7 is 105, 105 into 4, 2 raised to 2 is what? 4. That should be 420. So LCM is what? 420. So easily you can convert the numbers as a form of prime factors, and by applying that prime factors you can convert it into the numbers, and by using that you can easily convert in a form of HCF and LCM. Okay, very easy. Slightly example we also taken 17, 23 and 29. Another one example I'll take 17, 23 and 29. Once again another example we'll take as a part of the HCF and LCM. So make the common factors of 17, 23 and 29. 17 into 23 into 29. So it's all are the odd numbers. Okay, if it all are the odd numbers and you see that it cannot be converted in a form of prime factors, so we'll write here 1 into 17, 1 into 23 and 1 into 29. Okay, so there is no any common numbers, only 1 is there, only 1 is there. So which are the common term of HCF? That is 1. HCF, there is no any common term, so HCF always be 1. 17, 23 and 29, HCF will be 1. And for the LCM that is the multiplication of that numbers 17, 23 and 29 is equal to 17 into 23 into 29. So 17 into 23 into 29, that is 13339, that is generally your LCM. So just we find the LCM by using these numbers as a converting of prime factors. Now I'll use another one example that should be give a clear idea. 8, 9 and 25. I'll use another example. 8, 9 and 25. 8, 9 and 25. How can we find the HCF and LCM these numbers? So first of all 8 is there, then 9 and then 25. So if you convert in a prime factor, 2 raised to 3, that is 8. 2 to the 4 to the 8. 2 raised to 3 is 8. 9 it means what? 3 square. And 25 it means what? 5 square. Okay. Now we'll compare this number to find out the HCF of 8, 9 and 25 and LCM 8, 9 and 25. Now to find out the LCF, so HCF, when we find the common numbers in all three terms 8, 9 and 25 which have the common number, that is called HCF. So 8 having the number 2, 9 having the number 3, 25 having the 5. So there is no any common number. So if there is no any common number, HCF always be 1. HCF always be what? 1. Now LCM is what? This is a multiplication of all three numbers 8, 9 and 25. 8, 9 and 25. 72 into 25, that is 1800. So LCM is what? 1800. So by using that, you generally convert the numbers in a form of prime factors and you just find LCM and HCF of these two numbers. So this is the one of the examples in which we'll just compare or convert the number in a form of HCF and LCM by using the prime factorization method. Okay. So today only we are discussing how the numbers that is converted into the prime factorization and how we can find the HCF and LCM by using this prime factorization method. When we discuss other topics that we'll discuss tomorrow, in which we just use the Euclid's division algorithm and find out the two numbers of LCM. Also we have to prove that the numbers are rational or irrational and how it can be converted into the form of decimal. Okay. So till today we are discussing only HCF and LCM through the prime factorization method, how it can be converted into prime factorization and how we can find the HCF and LCM, and how the verification of HCM into LCM is equal to verification of two numbers. Now remaining questions which is in a part of exercise, which is maybe 1.2 or 1.3 or whatever the question in illustration, that you have to solve in your notebook, and remaining questions that we will be discussing onto the tomorrow's lecture. Tomorrow we will discussing about the rational and irrational topic. Okay, bye.